So yesterday one of the demo was not working, so I've rectified that. So let me go to that server. It's Jenkins. The IP is this, and let's open this server. Now let's check because now let's check one of these. So yesterday when we were deploying this Tomcat using CI/CD pipeline, there was error. So later it was success. So after fixing the bug, so let's check it. Let's check this URL. It is going to deploy on 100 41 90 90 it says. So let's check that. Let's open that IP and check whether that is up and running or not. So I think it's the same IP 8090. So I'll just change that to 8090. So logging into the account, just a second. So let's go and check the instance. So in this instance, we need to check whether the 8090 port is up and running or not. 090. So it is not running. Maybe so we are going to instances here. So checking the security group, whether it is open or not. 090 is open. So I will basically so I'm logging into that instance. The instance is so I'm checking the service now. So systemctl stop want to check once Tomcat service. Okay, so it should run from the user bin. So cd/user/bin Tomcat history. So it is user slash bin slash Tomcat. Okay, opt tomcat. So that is the location of Tomcat. So let's go and start that Tomcat and inside bin. Okay, we need sudo privileges to do that. So sudo minus I cd/opt. So I'm basically showing the yesterday's lab which I fixed. So of changes, and then Anush will carry on with Kubernetes and Angit will carry on with Terraform. Okay. Appreciate everyone's patience because these demos are little patience. Everything is not 100% accurate in this demo because these are really critical things to show. I should say complex than normal demos. So now we have a Tomcat running on 8090. There should be a Tomcat running and a Jenkins running. Jenkins will deploy to this Tomcat. So I'll change the IP to this. Tomcat URL will be this one. Okay. So I'll just remove this extra HTTP and save it. Okay. And let's do build. Let's take this and let's build it. So let's build from here. Let's go to Tomcat and do build. So build is going to build going to take the code from the GitHub and going to build. Yesterday we saw the steps, how it is taking that code, how it is integrated. So as you can see guys, till this point, if you come and see till this point, the build is success, and from here its deploying process is starting. It is deploying in this area, this war file. Okay, so when we go and see slash my app, it has deployed which, just let's check. It is my web, I guess. So just let's check here what it has deployed. Web app. Okay, web app. So let's do the web app. It's not my app, it is web app. So this is the text we had modified in the GitHub. Okay, so I'll log into the GitHub and change welcome to DevOps and AWS seminar, and then this page should automatically change to that. Okay, so I'll change in the GitHub. So I'll explain you what will happen here. So let's bring a drawing tool. So first okay, where is the drawing tool? Drawing tool. Why I'm not able to draw? What is the reason? Okay, and then let's bring a drawing tool. Yeah, so here is the Git. Basically, Git has one file, index.html, index.html. This is connected to Jenkins through a SSH plugin. Sorry, Git plugin, Jenkins, and it is going to deploy in Tomcat server. Tomcat server. So what is the guarantee that this is going on? To prove my point, what will I do is I'll go here and edit it. Welcome to AWS and DevOps demo class. And now when I commit here, it will get triggered automatically. It will start. It will know that there is some changes here in this file. Git will know, and Git will alert Jenkins. Once it is alerted, then Jenkins will start build process. Okay, build process, which comes under CI, continuous integration, and then CD will happen. That is, you can say continuous delivery or deployment. So delivery and deployment are similar. Okay, not very different. It's referring almost to the same thing. So it will go ahead and deploy it in Tomcat server. Okay, so the deployment will be a var file, which will have also this index.html. Okay, index.html, or there can be other file. Okay, I'm just giving an example of index.html. This is a Java project, so there will be a different file. Okay, so let's do this. So do you guys understood this CI/CD demo which I'm going to give? Yesterday I had explained. Those who had just joined, I have again tried to explain what the scenario is. Okay, once again I'll explain this scenario so that everyone are on the same page. They know that what demo is going on. Okay, so we have a Git. So Git is a versioning control. Okay, where we work distributedly on different type of code. Okay, and here Jenkins is there, where CI/CD is there. Okay, Git codes are going to push to Jenkins, and Jenkins is going to build that. Okay, and then Jenkins is going to deploy to Tomcat. Okay, so most of the in the old days, what we used to do is we used to manually go into the first. The developer needs to build the code in what he used to do, build the code in Visual Studio. Then they used to give us the package file. We need to take the package file and manually upload and then configure Tomcat in the web Tomcat directory, and then only it should be working. So there were many intervention of developer and DevOps, the system administrator. So now there are every second there's a new deployment happening. So software companies cannot take this process. It takes a long time. So that's why CI/CD. Now, if you see in the job market, whether internationally or locally, you'll see a lot of CI/CD knowledge being asked. You should have pipeline knowledge, AWS pipeline or Azure pipeline or CI/CD knowledge. You should have some type of Jenkins knowledge. So this is booming currently. So every second company is requiring this. Okay, that's why we have tried to give demo on this. So it's going to take the code. So code is from Git, and Jenkins is going to build. Okay, Jenkins will have Maven to build it. Okay, and it will be in var or jar. Okay, so currently we are creating a var package here, and Jenkins will directly deploy to Tomcat. Okay, so this is the scenario. So are you guys ready to see the demo? Let's go forward. If you have not understood, let me know. I'll explain once again, or after my demo I'll explain. Let's see further how it happens. So I'm going to log in into my Git. Okay, I'm going to change the file. So the file is hello world. Okay, this is the file which is pom.xml. So this pom.xml is a basically Maven project. So I'm going to go in web app. Here there is a file inside called index.jsp. So it's not index.html. HTML is a hypertext file, whereas JSP is a Java file. Okay. So let's do here. Welcome to DevOps and AWS workshop. Okay, so I did this, and let's take this out. This is present organized by CloudSewa. Okay, CloudSewa.cloud. Okay, so our company name, and then we do update the text and title. So same thing we are going to commit here. So we have changed our code. Okay, so now we should get, when we open the browser, we should get not welcome Bharat, we should get welcome to DevOps and AWS workshop organized by CloudSewa. Okay, so for that it needs to go to Jenkins, correct, according to the diagram currently. So we'll go to the dashboard, and if you go here and slowly look here, it is currently 19. So within every minute it will listen for any changes in Git. Okay, so let's check whether the new process is coming or not. So it almost takes 15 seconds, 15 to 20 seconds. So that's I'm refreshing it. So last build was 9:45. So this are okay, we got a build now, something is going on, so this is good. So I'm doing one touch installation. So I just changed the file, I being a developer. Okay, so the build and deploy will happen automatically. So DevOps is the person who is going to automate these things. Okay, again listen to it properly. Okay, this is the very essential thing a company wants from DevOps: automate the infrastructure. DevOps is the guy who lowers the time of different department. That's why people look after DevOps who has development idea about the software, maybe little, but he has some idea, and as well as ops. Ops means system administration. So when you mix these two, becomes DevOps. So with different DevOps tools, we should be able to do one single touch installation. Okay, so let's go here, and let's refresh this. So uh, the DevOps and AWS workshop, okay, has come and organized by CloudSewa. So what happened is, again one time, because this CI/CD is getting very popular, that's why it's required by every software company, every development hub. So here is Jenkins. Jenkins does the CI/CD part. Okay, and here is the Tomcat. Okay, Tomcat. So in the beginning, I was having a problem. This Tomcat service was not working. Okay, so that's why we need to start it again. Okay, So, guys, this demo was clear to you or unclear? Let me know so that we can proceed with another demo.
It's clear, sir.
Okay. Only one clear. Others. See, today's workshop is more concept, knowing what is DevOps, what we can do with DevOps. In one day, we cannot like learn all these technologies. It takes around good amount of 3 months. Okay, that's why we are starting a training this week, end of this week, and also with training we are providing internship opportunities also. Those who comes in training will get a free internship also. So you will be learning DevOps technology. Also, you will get an opportunity to work in DevOps as an intern in our company. Okay. So, okay, let's go ahead and start with another demo. Keep in touch with us. Okay. CloudSewa@gmail.com. You can always contact us there. Yeah. So Anush, you are ready? Should I give? Should I make you presenter?
Yes, sir.
Okay. So Anush, let me introduce Anush. Anush is an expert in Kubernetes and Docker. He has been working on production clients and helping different clients. Also training internal team. Last 3 to 4 months, he is deeply working day and night on Kubernetes and Docker. So hope, yeah, I'm wishing him all the best for the session, and I hope you guys get more aspect of DevOps from him. Yeah, over to you, Anush.
Okay, sir. Thank you, sir. Mm, Now first start with WordPress website. We'll make a we'll host a WordPress website with MySQL, and we'll make the volume persistent. So my with Docker Compose. First, let's check the Docker Compose file. So first, this is a Docker Compose file where we are specifying an image for MySQL 5.7, and we are also keeping a volumes for data persistent and some environments needed for the database like password, username, and also an WordPress image. We are pulling this image from a Docker Hub. So let's run this Docker Compose and let's see the result. So we start Docker Compose by doing Docker Compose up, and we created two images. This top two images, one is WordPress image and another is MySQL image. I mean container. We open to container and we can access this container in the port 8000. It's shown here. So we'll open this. We'll access this through a browser with port 8000. So this WordPress. So let's check the data persistence. Let's test the data persistent. Test.com. So if we customize anything in here, and if the container goes down by any problem, then when restarting the container, there's because of the data persistent, the changes should be saved, and when restarting, everything you customize should be there. So we put this theme here. So we put down this Docker Compose. Docker Compose down. So it should not show anything in here because the containers are down. No containers, no container. So again, when we lift up the containers, it shows the changes are intact. So this is because of the volumes that we specified in the Docker Compose file. Uh, this is my first demo. So let's move on to the next demo. Again, let's put this container down so it doesn't come in middle of other demos. So my other demo is an application which there are various containers. All the containers are connected to each other. Like we have a voting app which is made out of Python and a Redis database. This database is connected to this voting app, and there is a worker container which like after we vote, the vote goes to the Redis database. This worker node processes this data and uh, puts it in the Postgres database, and the data received by the Postgres is displayed on the result app. So there will be 5 containers. Let's see how we are doing. We'll do like the previous demo. We do this by Docker Compose. So we specify various containers in here, like this is a voting container, vote container. We build this image, and same like vote, we have result image, worker, redis. We specify everything in Docker Compose, and these are interlinked with each other, as this is a compose file and everything is connected. So we specify everything, like in database we need environment variables and password username, so we specify this. Let's run this image. So here are 5 containers that we just made: redis, voting app worker, voting app vote, postgres, and the result app. So we can access this application same like before, by looking at this port. The port of voting app is 5000, whereas the port of result app is 5001. So let's check it. This is the voting application. Mm. Like there are two options, cats and dog. If you vote dogs, then all the process will take place and the result will be 100% dogs. And if you choose cat, the result will be 100% cats. So this is a voting application demo which interlinked all the containers to each other, and accessing it by the in the browser through the public IP and the port specified in the Docker Compose file. The next demo we are gonna do is a Kubernetes demo. These two were the Docker demo.
So, Anush, I had some questions from the participants.
Yes, sir.
Like, can you explain a little bit about Docker file, Docker Compose? What is Docker Compose do, and little bit about it, and what is a Docker file, so that everyone gets the idea.
Okay, sir.
Yesterday, I had showed them simple Docker commands, like I run Nginx instance at Nginx container, and showed them a demo. So how does that demo differ from this demo? So give them a perspective so that they know that why we use Docker Compose and why we use Docker files.
Okay, sir. So the main importance of Docker Compose is we can run a lot of containers with one file, whereas when running from a command line like docker run, we have to specify each and every line for each and every container. So, and we have to link it. Different containers have different specifications, so we have to link and depend. It may depend upon various other containers. So Docker Compose makes it simple, as we can specify everything in a single file, so it gets interconnected with all the containers, and also with a single command like Docker Compose up, we can up the whole container, whole application with 5 containers or 10 containers. And we can if we need to put down the containers, we can do Docker Compose down, which is very simple and efficient. This is the main reason we use Docker Compose file instead of a command line like run and other run, mainly run. Uh, and a Docker file is for a custom image, like we just pull a WordPress image from a Docker hub. So if you want to make your own image, your own application, we have to make a Docker file and specify all your environments, infrastructure in Docker file, and then we can push it in the Docker hub. So others can use those, pull those images and use it. So mainly it's used for that purpose. Any other questions?
Thank you, Honest, for informative insight. So, anyone having question, please ask Honest, or you can send in chat also. You can ask in chat also.
So we'll do a demo of Kubernetes now. Let's do a kube mongo. Here we will run on MongoDB database, and we'll again access it from the browser through Mongo Express. So let's do it. We are going to do this by Kubernetes. So we have various files in here like secrets, Mongo, Mongo Express, and config file. These have different purposes. Like in secrets, we keep the uh, confidential files, keys like passwords and usernames, uh, and we specify this secrets file in this mongo.yaml file. So in order for this mongo yaml file to run, we need a secret file as it contains all the passwords and other important files. Same like secrets, we have config file which keeps the, let's check the config file. Sudo nano. It keeps the database URL which is needed by the Mongo Express. So first we have to up the config file, then the Mongo Express file. So it's in a Kubernetes file we have to specify API version, kind we are making a config map, and its metadata means the name of the config map and data. This is a database URL, MongoDB service. This service we will specify in the Mongo Express file. So it is connected with each other. Let's look into a secrets file. Here we are specifying the database password, user and password. This is in a 64-bit format. This is an encrypted password. So we keep the secret file. Now let's check the database that we'll access from the browser. So this is the deployment.
Hello everyone. First of all, I'd like to introduce myself. I've been working on Terraform uh, in CloudSewa. So First of all, I would like to introduce with my presentation. So, what is Terraform basically? So, Terraform is a tool for building, changing, and versioning infrastructure safely and efficiently. Terraform can manage existing and popular services providers as well as custom in-house solutions. So, it's a tool used for changing and versioning infrastructure safely and efficiently. Okay. So it is an infrastructure as a code tool. So basically, when we change our infrastructure as a version and build our infrastructure, we do it as a code so that we don't have to actually manually configure everything, go to the AWS or any kind of other cloud services to manually configure the infrastructure. So infrastructure as a code, what does it mean? Infrastructure as a code is an infrastructure automation using software development principles and practices. The idea is that you treat the infrastructure like software and then write, test, and execute code to define, deploy, update, and deploy your infrastructure. So, likewise, what I just said, we define, update, deploy, and destroy our infrastructure in the infrastructure as a code tool. So, Terraform is an infrastructure as a code tool. And why use Terraform actually? So why do you really want to use Terraform? Terraform is an open source, which means you have access to the code to read, debug issues, and contribute to future releases. Terraform gets frequent updates and supports new providers every day. Configuration state can be stored in backends like AWS S3, Console, and Google Cloud Storage or PostgreSQL. It uses HashiCorp configuration language to build structured configuration language that is human and machine friendly. It is a fully JSON compatible and provides simple loops and conditions. Terraform makes use of commands, which means you can review the changes you are about to apply. So, how Terraform can provide solutions? Terraform can manage existing and popular services providers as well as custom in-house solutions. Configuration file describes the Terraform, the components needed to run a single application for your entire data center. So likewise, just what I just said, you can with a single file, you can actually manage configurations of a data center. So you can understand how powerful is Terraform. So Terraform generates an execution plan describing what it can do really to desired state and then executes it to build the described infrastructure. As the configuration changes, Terraform is able to determine what change and create incremental execution plan which can be applied. So features, what are the features of Terraform? You'd like to know that also. So as we can see, the features are infrastructure as a code, execution plans, resource graph, change automations. So we can do these with Terraform also. So how does Terraform work finally? So Terraform works as just simple commands with just simple commands. So uh, I believe okay. So likewise, how does Terraform work? So we can see in the slide. Okay, so just like I've said I'll start from the beginning in a short way. So it's a tool that's used for building, changing, and versioning. So define, update, deploy, and destroy. So why use Terraform? I've already said that before also. So how Terraform can provide solutions? Terraform can change managing existing and popular service providers as well as custom in-house solutions. Likewise, there are different ways that we can provide solutions with Terraform. So Terraform can be used to used as an infrastructure as a code uh, uh, to configure the whole provision the whole data centers infrastructure also, like we can see in number two. So I've already told the features of Terraform and how Terraform works. I was here. I'm sorry for the inconvenience though. I thought like my screen was sharing, but then I had no idea that uh, it was not sharing. So I was just going in my flow, and I had no idea that I was not presenting the presentation. So right now I will start again. Um, so what does actually Terraform? How does actually Terraform work? So many of you might have these kind of questions. So Terraform actually works with initializing the infrastructure, planning the infrastructure, and applying the infrastructure. The main code that we actually use in Terraform is init, plan, and apply. So basically, we have just three codes that we frequently use that will change the whole infrastructure in the cloud. Okay, so let's start with the demo. I've already prepared some codes in my machine so that I will start from there. Okay, so we can see that I have created some codes here. So first we need to configure our infrastructure. So the provider is going to be AWS, reason is going to be, okay, first let's start with the AWS account, how it works. So when we go to the instances, we can see that there is no instances right now. And our region is Mumbai, which is AP South 1. So basically how it works is that we have already defined our region as AP South 1. So we need to first create a VPC, and then we need to provide our access keys and secret keys to actually access the AWS account. So this is a mandatory thing so that we can access it. And then the next thing that we need to do is that we need to create a VPC. So we create a VPC and then internet gateway integrated with the VPC. As we can see, AWS VPC prod.vpc is integrated with its ID. Its ID is integrated with VPC. So we can see that um, it's integrated. So we create custom route tables, and then which is also integrated with VPC ID, and then subnets, which is also integrated with VPC ID, and basically and so on, like associate subnet with route table, and then create security group to allow port 22 ATN 44 443. Sorry. So this is how Terraform configuration file looks like. And then we need to actually we everything that we do in AWS account here uh, is reflected in this code, so that when I run this code, we can see that the AWS account will have some changes. So first of all, I'll start with explaining the codes, and then creating network interface card with an IP. The subnet was created in step 4. We can see that here in step 4. So subnet IT is associated here. So likewise, elastic IP to the network in step 7. So we have created a EIP, and then which is associated with network interface card created in step 7, and then that's how we define Terraform codes. And basically this is a code that I am trying to deploy for a EC2 instance. EC2 instance means a web server where we are running Ubuntu server. So basically I'm running a Ubuntu server in the cloud. So this is the AMI image, Amazon machine image, which is the we can define it here. And then which is the type is T2 micro, and the key name is this is the file which I will be using to actually go inside the instance. So I will show that in next demo. So basically this is all I have done. I have created, and then inside okay, fine, but then I have already created a Ubuntu web server in the cloud. So basically what I want to do is I want to create a Nginx Apache 2 server inside that uh, machine. So basically I will be providing a EOF code here, and then sending it to the var www dot var slash www slash html slash index.html, where I will be just writing your first web server. So basically this is a script that I've written here. So user data represents a script. So when you actually start with a script, when you actually write a script here and then in the user data, it directly reflects in the cloud server. So this is how it's going to happen. Okay. So and I have declared some output with which it's easier for me to actually access the website's IP, public IP. So I will start with Terraform initialization. Just like I've said in the slide, here I will show you again. Terraform init. So init, plan and apply. So that's how actually I'm going to actually do it. So I'll first initialize the command. Okay, it's successful. We can see that the initialization thing is successful, right? So, okay. And then the next thing that I will do is plan. So we can see after planning, we have certain kind of things that will actually we will, before applying the thing, that configuration that we want to in the cloud. So we need to first plan and look at it. Is it going as I have written in the code, so that we can change before applying. So we will look as written in the code if it's right or not. So we can see everything is already defined here: network interface, NIC, internet gateway, and so on, right? So now we are going to apply this. Okay, here we go. We need to type yes. It'll take some time. Please be patient with it. So we can see our VPC is being created. So basically what it happens is like when we create it here, we can see that if you go to the VPC thing, VPC option here, and okay, let's search here. I think my internet is working slow. Okay, here it is. It'll take some time. Still creating, it's taking some time actually. I guess it's because of my internet. Also, because of the bandwidth that it's consuming right now. So I think it has already created the VPC, and we can see that our VPC is created here. So we can go to the VPC thing, and we can see that our production VPC is already created as we have defined here in the VPC thing. VPC in the configuration file. So everything that we do will be created in the AWS account in the file here. Okay, production name is equals to production, right? So we can see. So uh, okay, the production is already here. Now let's go to EC2 instance. We want to see the EC2 instance is running or not. So okay, it's getting created slowly. So it's not complete yet, right? So let's wait for a while and then let's see if it's getting created or not. Okay, finally it's created, right, everyone? So we can see that it's already created here, and then EC2 instance is already created. We can see that it's already associated with different VPC. Here it's here VPC ID, production, and product subnet. It's already also being associated, and it has given us our public IP also, through which we are going to actually see that. So through which we are actually going to see if our this thing that we defined here, this your very first web server is going to load or not in the public IP. So let's go and check it out. Okay, now we need to actually go here and just paste it here and look. Okay, it's running very good. So basically now this is my first demo. So do you have any questions in relation to this first demo? I will show you another thing actually. Wait. So what we need to do is, first of all, we need to go here, and then the key that I've defined in my Terraform. Uh, Wait, I will show you that also. Okay, the key name that I've defined in my Terraform is main dash pem key, right? Which key is actually that we create in the AWS account to access our EC2 instance. So what we do is we use this key. We need to download this key from the AWS account when we create it. So what we do is actually I will show you how it's done also. So I won't download it, but I will show you how it's done. So when we actually prepare a key, we need to go to the PK key pairs, and then we can see that it's main slash pem key, right? So this key actually I've already downloaded. We can download it only once, so we need to keep this key very safe, so that when we actually use this key to again in different instances, we can actually access those EC2 instances, I mean web server, Ubuntu web server, with this key, so that we need to keep it very safe. Okay. The next thing that I want to do is actually SSH into this key. So basically what I want to do is I want to go to the EC2 instance first, and then look into this public. Okay, here. No, I want to connect it here so that it directly shows me what to do. Okay, this. And I just need to paste it here, nothing more. And here we can see we are already getting it connected inside this server. So we can see our IP is 10.0 dot this according to our 3.108. So and then what we want to do is actually we want to see if it's getting our file which we created has been created or not. Inside cd bar slash html and check it inside index.html. So right, what we did here actually reflected here, right? So we can see that your very first web server has been created. So I will now go to the next demo. Okay, so basically I have to first destroy my infrastructure so that I can run a next demo, because I don't want my Terraform state file, which is here present here, changed at the moment before destroying, because this is a file where it stores everything, like whatever we do in the Terraform infrastructure, it stores here. So it stores even like credentials, and it needs to be very safe. Okay, we need to keep this file very safe, so that we need to keep it very safe. So basically what I want to do is actually right now I want to actually just destroy this thing. So I will just go to my VS Code and destroy my infrastructure now. So as I also want to indicate something before like destroying this thing. Okay, I have written a output variable here, output resource block here, so that we can see that it created some outputs with which I can actually The IP which we can directly copy this IP so that it's very easy and I don't have to actually log in into the AWS instance thing, and then I'll just copy and paste and it shows here. So I created it so that it makes it easier. And okay, I'm going to destroy it now. So it's taking some time. We need to refresh that state file, right? Like I said, that state file needs to change before getting destroyed. Everything that we have in the state file will disappear. Okay, it's completely destroyed. Like we can see, our resources nine resources have been destroyed. So I will now start my second demo. I have two demos today. So I will the first demo was just running a EC2 instance, and my second demo will be running multiple clusters of EC2 instance. So this is my file, which I'm going to delete it for now, and I will show you my Terraform state file. So basically, when we can see, we don't have anything that we had before, right? So it's already destroyed everything that we actually did. I will show you my uh, EC2 instance also, okay? So that we can see inside the EC2 instance, there is no instances here. We just destroyed with command line interface, I mean infrastructure as a code. So uh, we can see that in the infrastructure as a code, we destroyed it with Terraform and it reflected here. So the next thing that I want to do is actually delete this file which I created for my first demo. I will delete it, simply delete it. So I will just put my second demo's file here, copy and paste, and I will explain it. So we can see that our second demo file is a little bit different. We have provided the credentials like before, AWS, and then we have created VPC, we have created internet gateway and custom route table, uh, subnet. Wait, this is not the file that I want to show, or is it? Okay. mm, Wait, I have this file backed up somewhere. Okay, why is it not changing here? Oh, wait, I'll delete this file first and go to the demo file. I have to copy this, paste it here. Let's see. Okay, like I've just looked at, now we can see I was just going through my old file. Actually, that was a mistake that I did. So we can see our new file here, uh, and then we can see our new file. We have provided our credentials, like we had to access key and secret key here, and our reason is the same. So basically, we have created a availability zone to all, so that we can see it can spin up in all the availability data centers available in this AP South one. So, and then the next thing that we did is create an auto scaling group. So our minimum infrastructure scaling will be 2, and then maximum will be 10. So basically 2 infrastructure should be running in the cloud. As we can see, if one thing fails, another should be running, right? Server should be running, right? So that's how we've like put this demo, so that we can show you the real-time scenario, how the cloud works actually, how the cloud server runs. So I have created a busy box, which is a scripting tool which can actually provide a HTTP function to run some commands, which is already inbuilt thing that we can see in the Ubuntu machine. So we've created a EC2 instance with the same image as before, and it's going to be instance type is going to be T2 micro. EC2 instance means Ubuntu server that we are running AMI with the AMI image associated, like EC2 instance. Inside the EC2 instance we can see that it's a Ubuntu server. So we have created lifecycle create before destroy. This is also true, so that infrastructure actually is created before and then destroyed. And then we have created some AWS security group. Here we have created a var.server port, which is actually variables.tf file associated with it. So server port is associated with variables.tf file here, right? And then another thing that we can see is SSH, that I have not specified with the variables file, but I have just created a port number, which is a default port number for SSH. And then we can see another thing. We have created elastic load balancer, which actually balances the multiple instances running together. So this is how I have done thing, and then the security group and everything is configured here as I wanted. So let's just run and look at it if it's doing as I wanted it or not. Terraform init. Okay, what happened here? Okay, sorry, there is a mistake here. Okay, let's plan the thing. Okay, it's running as I wanted. So the next thing that I want to do is apply, right? And we're going to do yes. Okay, it's creating as I wanted. Everything will be created shortly, and I will show you how it happened. in the AWS account. I think it's getting created. It's getting created actually. It's getting created like I've mentioned in the IAC infrastructure as a code Terraform configuration file. So this is how what I've done here. It's directly reflecting to the code to the infrastructure in the AWS server. So it's slowly creating. It's taking some time, but then will be created. Doing this manually would be a little bit tough thing, but then as an infrastructure as a code, we can actually do it in a very simple way, right? So this is a very important thing. So auto scaling group is getting created right now. Okay, now it's finally created. So let's go and look if it's running actually like I wanted it or not. So let's first look at the EC2 instance. Okay, like I said, minimum should be two instances are running like I have defined here. So basically, whatever I have defined here, okay, two instances. Let's go and see. Mm, okay, like I have defined here. Mm, where is that load balancer? Okay, like you can see, the load balancer's name is a Terraform AST example, right? So we're not going to actually take the IP of a Elastic, I mean EC2 instance here because it's a different thing. We are balancing the both the infrastructure that we made together, which replicates each other, so that we can see our DNS name. We'll be taking our DNS name of our load balancer. Okay, so we will be taking this and then simply copying this and look if hello world that I have written here, I guess it should be there. Yes, hello world, right? Is running or not? Okay, it's running, right? So this is the demo. Now I'll explain a little bit about how this thing is interrelated to each other. So I have some output.tf and variables.tf file here separately mentioned. I mentioned that file before in the main.tf, but I have mentioned it here in a different way here, output.tf, so that I can create this output here in relation to AWS Elastic Load Balancer example.dns.name. So this is a dash name. So this is how I uh, brought this DNS name, and then we can see here also. Yeah, this is the DNS name, and so what I want to do is next is variables.tf file. So I've defined our variables.tf file here too. And then in the main.tf, actually, I'm just writing var.server port so that this thing is reflected in different code, right? Different resource block, right? So this is the resource block, and then it's being reflected in different thing. Let's search where is var dot. Okay, server. Okay, we can see here it's being reflected here, multiple places, right? So I've just defined in the variables file so that I don't have to actually we can use the same thing again and again for different purpose. That's how we actually define variables file, and this is the basic of Terraform, and then there are more to know. So my demo concludes here. um, is there any question that you want to ask? You can ask right now.
Yeah, thank you everyone. Thank you team, Anush, Ankit, Ishwar, for this effort. Thank you.